dy dx is equals to, if we differentiate 2x, okay, differentiate x squared, we are going to get 2x. Okay, we'll get 2x when we differentiate 2x. So here, if we differentiate 6x here, we are going to get 6, right? So if we differentiate 6x, we'll get 6 here, right? That's minus 6 we got in here. If we differentiate a constant, we'll get 0, so nothing will remain here. So this is the differential value. But we are told that here, that at what point is the gradient of the curve equal to 0? Now that we have found our gradient is dy dx. Our gradient is dy dx. So now that we have found dy dx, we are going to equate this dy dx to 0. We will equate it to 0. So it means that dy dx is equal to what? 0. That is the implication, right? We are equating dy dx to 0. If we do that, it means that we have our 2x minus 6 equal to 0, right? So our 2x minus 6 is equal to 0. Then we are simply going to transfer this minus 6 to the right-hand side. And when we transfer 2x minus 6 to the right-hand side, it changes to plus 6. Okay, we are adding this to the other side. So it changes to 0 plus 6. 0 plus 6. Now this is 0, 0 here. Then plus 6. Okay. This we apologize for the sound you are hearing now. Because it's due to, so please bear with me. The sound we are hearing now is a simple sound coming from explosions. Right? This is usual during Christmas period. So here we are going to have 2x equals to 0 plus 6. So when we add 0 to 6, we are going to get 6 here. All right? So what it means is that we have to divide both sides by 2. So when we do that, we have 2 here, and here we have 6 divided by 2. All right? So we have divided by 2. So here, these 2 will nullify themselves, cancel each other. We'll now be left with x equals 6 divided by 2 is 3. All right? So this is 3. X is equals to 3. This is the value of x at that point, okay, where the gradient is equals to 0. So this is the answer to that. This is the point. So that's what we are looking for. So we have to find the value of that at that point, at which the gradient is 0. So x is equal to 3. So if you substitute x equals to 3 in this expression, substitute x equals to 3 in this expression, we are going to get the gradient equal to 0. So this is the point where the gradient is equal to 0. All right? Then if we are told to find the coordinate of the point, and that's when we'll now be looking at this one. But the point is actually 2x minus 6. And that's what we have for this. And I hope you understood what I have done so far. Thank you very much, and welcome to Mathematical Weekend on AZ Science TV. Okay? AZ Science TV is committed to streaming mathematics solutions live. We believe that students are finding some of these questions very difficult, kind of, right? Because I can see in some of my comments and live chats previously, even yesterday, the one we did yesterday, students were asking for calculus. So which means that calculus is a major disturbing factor for students. So this is why we have committed our weekends, our mathematical weekends, to calculus, including differentiation and integration. We are into differentiation now, but very soon we'll move into integration, and we do hope that you're going to find values in our videos. Please, if you are joining me for the first time and you have not subscribed, please do well to smash the subscribe button. Okay, be a part of AZ Science TV so that you can keep getting our packages We are very much committed to streaming mathematics live. So for those that are joining us right now, please do it to smash the subscribe button. Okay, let me repeat what I've said so far. Today, we are still looking at differential calculus. Okay, it's also calculus. Differential calculus means differentiation, right? And today we are looking at the applications of differentiation, right? So the number one application is gradient, okay? The applications around gradient. That is the number one application of differential calculus, okay? So the question one here is that at what point is the gradient of this curve? You know, this is a quadratic curve, right? So at what point is the gradient of this curve equal to 0? That is what we are talking about here. Now, the first thing we are going to do, since we are already given the function here is x squared minus 6x minus 3. So that is the function. Now we are going to get the gradient, okay? Gradient is simply the ratio of change in y to change in x. That's what gradient is. And since we can differentiate this expression, get dy dx. Okay, this is our y. Our y is equals to x squared minus 6x minus 3. Then we are going to get dy dx. Okay, dy dx means differentiate y with respect to x. So that was what we did here. If we differentiate x squared, we'll get 2x. Then if we differentiate minus 6x, the minus will disappear, leaving us with minus 6. Then if we differentiate 3, the 3 goes out completely, okay? So the differentiation of any constant is equals to 0. So there's no point. So the 3 disappears automatically, leaving us with only this expression, right? But remember that we are told that the gradient of the curve is equal to what? 0, which means since we have found the gradient, we are going to equate it to 0, right? That is what it implies. Therefore, 2x minus 6 is equal to 0, right? So which means we can transfer minus 6 to this side, becomes 2s equals to 0 plus 6. And 2s becomes 0 plus 6 is 6 here. So which means we have 2x divided by 2 is equals to 6 divided by 2. And that gives us, this 2 will cancel each other, okay? Leaving us with x here equals to 6 divided by 2 is equals to 3. So this is the solution to this particular question. So thank you very much and welcome to AZ Science TV. We appreciate you for coming and for making us, for spending part of your weekend with us. So this is Mathematical Weekend on AZ Science TV. So wherever you are watching us from, for joining us. Okay, this weekend will be one of your best weekend. So mathematically inclined. So thank you for making your weekend mathematically oriented by joining us. So we do hope that you are finding value here. Please do it to smash the subscribe button if you have not. And we'll be more than happy to always have you in our midst. So thank you very much. Now we'll be going to the next question to see how far we can go for today's edition of the Mathematical Weekend class. So now we have the second question. In this question, we are told to find the coordinates of the point at which the gradient of the curve y equals x squared minus x plus 4 equals 3. So it's the same thing. Remember the other one. What was that we decided we are giving the equals to 0. All right. But this time, please, the gradient of the this is no longer 0, that is 3. So it is more like the first one. But the first one we equated to 0, but here we are equating to 3. That's what we are doing to the end in this question. We are equating this one to this particular one to 3. So the answer is going to take this form. We are going to have it in this manner, right? We are going to have dy dx. Don't forget that we have our y equals s squared minus x plus 4, right? And then we are going to have our gradient. So our gradient is the change in y, which is the y, then change in x, which is the x. So this is our gradient. Okay, this is dy dx. That is the gradient. So if we do that to this, we are going to have our gradient to be what? Sorry, we are going to have our gradient to be differentiate x squared. Okay, it will be 2x, then minus 1. We have, if you differentiate x squared becomes 2x. Then if you differentiate minus x, we are going to get 1, right? With respect to x. Then the differentiation of the constant is 0. So the constant has no value after differentiation. Please take note of this. This is what we have as our gradient. But remember that we are told that this gradient, which is 2x minus 1, is equals to what? Is equals to 3. That's what we are told, all right? We are told that when we differentiate it, we are going to get 3 as our answer, right? So what it implies is this is x squared minus x plus this equals 3. So you can see what we have here, all right? So we are going to differentiate this, which we have done, then equate it, right? We equate to 3. So since we have equated to 3 and no longer, we are now going to have 2x. So when we change this, okay, change the position of this, transfer to the next, to the opposite side, we'll have our 2x equals to 3 plus 1, right? 3 plus 1. So that gives us 2x equals to 4, right? So this 3 plus 1, that gives us 4. Okay, that gives us 4. Then the next phase is both sides by 2. Okay, if we divide both sides by 2, we are going to have 2x divided by 2. Then here, by 2 again, we're going to have 4 divided by 2. Right? So, as usual, our 2, we cancel these 2, leaving us with x here. Okay? Then here, we divide by 2, and that gives us 2. Here, this is x. Please, this is not the coordinates. Coordinates is always 2 numbers. Okay, for coordinates, we always have for coordinates. When you have coordinates, when we write the word coordinates like this, coordinate is always written as what? As bracket like this. One, the first number will be x, then the second will be y. Okay, this is how coordinates are usually written. Okay, with the bracket. The bracket is usually indicated here. Then we have 2 numbers here. Okay, the first number here is always x, which is going to be our 2 here, right? Then the next number will be y. All right, that is what we call coordinates. Please don't forget that. Now, how do we get our y? We are going to get our y by substituting into this original equation. All right, so it means we are going to have something like this. Bear with me. Sometimes we experience some of this noise because the the academy is situated close to the road. Okay, now here, to get y, okay, to get y, substitute, okay, substitute, we are going to substitute into this. So we have y, look at it. We are going to substitute into this particular equation or expression. And this is y equals s squared minus x plus 4. So we substitute the value of x here, which is 2. So this gives us 2 squared. Okay, that's 2 squared. Then minus 2 plus 4. Right? 2 squared minus 2 plus 4. That's all we have here. So this gives us 2 squared is 4. Right? Then minus 2. Then plus 4. Right? That is for y. So it means that 4 plus 4. This is 4 plus 4. Okay, we can have a 4 plus 4, then minus 2. We can rearrange it like this. All right, since these two are plus and plus. So this gives us y equals to 4 plus 4 is 8, then minus 2. And y finally gives us 6. Y finally gives us 6. That is the value for y. Okay, then the coordinates now. The coordinates is now going to be what? Look at the x and y. So the coordinates of the point, we are going to have our coordinates now written. No longer with x and y, but with the real numbers. Coordinates of the point is now what? Just put in your bracket here. Okay, our coordinates, let's write it here. It's going to be x. X is the first number, which is 2. All right, that's 2. And y is 6. Y is 6. So this is the answer to this particular question, right? So we have to find the coordinates of the point at which the gradient of the curve is 3. The gradient of this curve, the curve of this function is 3, right? So that's what we're getting here. This is the coordinates. So thank you very much for joining me. This is AZ Science TV. We are committed to doing a lot of streaming live mathematical solutions, all right? So students have been complaining, have been telling me a lot about differentiation, about calculus. So that's why we have decided to bring calculus to the fore. We are trying to make sure that calculus is simplified as far as we can so that students can find it very easy. We want mathematics to be fun. We want to enjoy mathematics as much as you are learning. Okay, we should not just be learning mathematics and be afraid. We shouldn't be scared of the way they are done. Okay, it's very simple. Mathematics is all about principles. For instance, here we are told to find coordinates. We need to understand what coordinates are. All right, coordinates are usually represented with 2 numbers. It's different from when we say find the value of x at the point where the gradient is equal to 3. If we are to find the value of x at the point where the gradient is 3, then we'll stop at this level. Then here we are told to find the coordinates. And coordinates consist of both x and y. So which means when we find the x value, when we are done finding the x value, then we have to go back to the original function. Okay? Then we substitute the value of x so that we can get the value for y. X is the independent variable, while y depends on x. So y is the dependent variable. Please, let's try to understand this, okay? So, and we are going to be very happy in our class today. So thank you for joining me. If you are joining for the first time and subscribe, please do it to smash the subscribe button so that you can always be a beneficiary of the wonderful packages we have for you in AZ Science TV. AZ Science TV is committed to live streaming mathematical solutions online directly, okay? Although we have videos, both short and long, but streaming live to us is the best because students learn better when they learn live, all right? So thank you very much. Do well to share and like our video, okay? And if you have any comments or suggestions or anything, please put it in the comment section. We'll be more than happy to take your suggestions, okay? Now, the reason for this lesson is because students have been suggesting calculus to us. So it means that your comments and suggestions are very much important. In fact, they determine the way we operate this channel, all right? Because the viewers, our audience are those who actually control the channel because they are in charge. Whatever you say we should do, we always consider it because you are the ones making this channel to live. So thank you very much for joining us. Now, I'm going to repeat what I have said here, right? Question 1 is that we should find it. Okay, this is question number 2. We have done the first one. So here, we have to find the coordinates of the point at which the gradient of the curve, this curve is 3. So this is the function, okay, at what point is 3, which means we are going to get the gradient. So we are going to differentiate this, find dy dx. This is y already. So we are going to find dy dx of this function. Once we get dy dx of this function, we equate it to 3. Is means equal. Then this is 3, all right? So since our function is given as y equals x squared minus x plus 4, our gradient is dy dx, okay? dy dx equals 2x minus 1. Yes, dy dx means differentiate y with respect to x. So this is our y, all right? These are y. We are going to differentiate with respect to what? X. So if we differentiate x squared, we are going to get 2x. If we differentiate minus x, we will get minus 1, right? Because the differential of a function, okay, that has x equals 1 is, will give you the coefficient. So the letter will disappear, leaving us with the constant left there. Then the third one is this: the differentiation of any constant 1 to any number is 0. All right, there's a proof for that. We'll do that now next, maybe subsequent class, right? But today we are focusing on the applications of differentiation, and the subtopic we are looking at under applications of differentiation is gradient, right? We are looking at gradient. So after gradient, we'll look at turning points. But right now it's gradient that we're looking at. Now that we have differentiated, we are told to differentiate. That is the gradient. Okay, this is the function we have gotten. This is the differential function. What you call differential. This. When you differentiate, what you get is the differential of what? Of the original function. Okay, differential function of this original function is what we got here. But remember, we are told to equate it to 3. That's why the word is coming here. Okay, because the gradient is 3. Now that we have gotten the gradient, we equate it to 3. So that's what we got here. This was the gradient, okay? Or this is the gradient rather, and it's equals to 3. Then transfer minus 1 to the right hand side. Okay, that gives us 3 plus 1, which is 4, leaving us with 2x here. Then we can divide both sides by 2. Okay, and that equals 4 divided by 2, and here divided by 2. So which means 2 will cancel each other, leaving us with x here. Then 4 divided by 2 is 2. Remember, we are not just told to find the value of y or x. We are told to find the coordinates. So, and coordinates always have 2 numbers. Okay, the coordinates of any point is usually denoted with 2 numbers enclosed inside bracket, and the first number is usually represented by x. Okay, then the second one is y. So which means we have gotten our x now. All right, we got our x here, but we don't know y. How do we get y? What we simply have to do to get y is to substitute the value of x into the original expression. So we'll come here and substitute for x, right? That's what we did here. To get y, y equals x squared minus x plus 4, which is this expression, right? Now it's time to substitute for x, which means whenever we find x, we put 2 here, right? Look at it, this x, so this is 2, and it is squared, so 2 will be squared here. Then minus, right? Then x is 2 here too, then plus 4, all right? That's what it means. And please, let's follow it gradually. Then the square of 2 is 4. That is 2 times 2 is 4. Then minus 2, then plus 4. Okay? Then we can bring these positives together for better understanding, okay? Or using board mass, order of operation. Addition comes before subtraction, don't forget. So we are going to bring the plus and plus together. So we are bringing plus and plus together. Then the minus comes last. 4 plus 4 will give us 8, then minus 2, right? So 8 minus 2 is 6, which means our y is 6 and our x is 2. Now we can substitute for x and y, okay, to give us the coordinate of the points. So this is 2, for x, okay, which is this x, all right, and for y, we have 6. So you can see here. So this was how we got the solution to this question. So I hope you understood this. I appreciate the fact that you are with me. We are very much grateful to have you in today's show. So if you are joining me for the first time, please, this is known as Mathematical Weekend. Okay, that is the theme of our weekend shows, which take place on Saturdays, usually from 9 to 10:30. All right, it takes place every weekend. So I do hope that you are deriving value in my videos. So please, if you are deriving value and you have not subscribed, please just smash the subscribe button just to encourage us and keep us going. All right, because you are the spirit behind this. If you do not motivate us, we are going to be kind of getting discouraged. So, but your presence here has shown that you are very much ready to keep encouraging us so that we can keep moving. So thank you very much for joining me. I appreciate you. Okay. So now we are going to take the very next question for today. So here we are told to find the gradient of the function. Okay, we are told to find the gradient of the curve. This is the function that represents the curve. Then at the point where x is equals to 1. So this curve is given by the expression. So the answer is going to be in this form. The question is a very straightforward and simple question. In this case, please, we are going to note it, note certain point, all right? Remember, we are finding the gradient, which means there must be dy dx, right? Then when we get dy dx, don't forget, we are not equating to this, okay? Here we are giving x already, so we are not equating to find x or find y. Here, we are to find the gradient, which means after differentiating, substitute for x, then we get our answers, all right? So that's what we are going to do here. So what it means that we have y equals 2 root x, then minus 1 over x. So this is what we have. We are going to rewrite this expression so that it will be easier for us to differentiate. This x raised power square root means raised power half. Okay, raised power half. That's what square root signifies. Then minus this is plus. So this means x raised power minus 1. So these are the two ways to express these things. All right. Now that we have gotten our y as this, it is time to find dy dx because gradient is equals to dy dx. So what it means is that gradient is equals to what? Dy dx. Dy dx. Okay? And this dy dx is what we are going to use here. All right? Since we are applying differentiation here. So it means dy dx is, let's apply the dy dx here. If we apply dy dx, don't forget, when differentiating, this number here will be used to multiply what is here. Okay, that means 2 times half. We know that 2 times half is 1. So that gives us 1. Okay, x. We are not supposed to put it there. I'm just putting it for the sake of putting it. Half times 1, or half of 2 rather. Half times 2 is 1. All right. Then this is x. Then we are going to subtract 1 from half. 1 from half. Look at it. 1 from half. Okay. To subtract 1 from half is simple. Okay. And this is half minus 1. Look at it. Remember, 1, if you take half from 1, we are going to get half. But this time we are taking 1 from half, which means we are taking a bigger number from a smaller number. So we are going to have minus half here. Okay? We are going to have minus half here because we are subtracting 1 from half. We'll have minus half here. Then this other side, this particular side, we have minus. When we bring, listen, look at it. Just look at this. This is minus 1. When we bring it this way to multiply the minus 1 here, we will get plus. Right? This will get plus here. Then x minus 2. All right? Because we multiply, we are going to use this minus 1 to multiply the minus 1 here. That will give us plus 1. Okay? Plus 1 here. All right? Then we'll subtract minus 1 from here. Minus 1 will give us minus 2. So you subtract minus 1 from minus 1. Here we have minus 1 already. Then we minus another 1. That gives us minus 2. Remember multiplication. This is addition of 2 negatives. That gives us minus. So when we add 2 negatives, we are still going to get negatives. All right? So this is what we are going to get as our answer. So we can then go ahead and remember we are going to substitute for x anyway. But before then, let's find a way to transform this one to this form. Okay? Then it means that our 1 is not necessary. Or if you think it's necessary, then put it as 1 divided by, this is x, right? This is x raised by half. This is x raised by half. Then plus 1 again. Remember there was 1 here, which we are not supposed to put it, but let's just put it for the sake of putting it, okay? So this 1 will now be 1. It is this one that becomes this 1. Don't forget. Then divided by x squared. Okay? S squared. Look at it. So we can go ahead and have a 1 divided by the root of x. The root of x. Don't forget, root of x means x raised by half. Okay? So this is x. X raised by half is something as square root of x. Then this becomes 1 over x squared here. All right? So this is our gradient. This is our dy dx, which is the gradient. So that's what we got here. But what we are going to do, remember, we are told to find the gradient, which means there's a number. Okay, the gradient is a number. Find the gradient of the curve at the point where x is equal to 1. Now it is time for substitution. We are going to put x equal to 1. We'll put 1 wherever we find x in this gradient. Remember, this is gradient. So put x to find the gradient. Put x where we have put 1 where we have x. So that's for the value of the gradient. Okay. So get the value of the gradient of the gradient. So to get the value of the gradient, substitute for x. Put x. Okay. So okay, let's say at the point x equals to 1. Okay, at the point x equals to 1, we are now going to have what? Dy dx equals to 1 divided by square root of, this is x, so and x is 1. So we put 1 here inside the square root, then plus. Okay, don't forget plus. Then we have 1 divided by this s square, okay, which is 1 square. All right, so this gives us 1 divided by 1, because the square root of 1 is 1, and this is plus 1 over 1, because the square of 1 is 1. Right, the square root of 1 is 1, the square of 1 is 1. This gives us 1 plus 1, because 1 divided by 1 is 1. 1 divided by 1 is 1. And at the end of the day, we'll end up having 2 as our answer. So we are going to end up having 2. Please, this 2 does not mean x. It means the gradient of this function, okay? The gradient of this curve